Hello students, welcome back to the next module of the chapter Oscillation. Students, in the initial modules I have already defined time period and frequency. In this module, we'll derive an expression for time period and frequency. So let's start with time period or period of SHM. As we already know, time period is nothing but the time taken by a particle performing SHM to complete one oscillation. Now, let's derive an expression for it. So, consider a straight line path LOR and let us assume at time t is equal to 0, the particle is at positive extreme. So, students, we know from initial modules, if the particle starts from right extreme or positive extreme, the displacement equation will be given as x is equal to a cos omega t. Now, at t is equal to 0, I can write omega t is also 0. Therefore, our right hand side becomes x is equal to a cos 0. Cos 0 is 1 and hence students x is equal to a. That means at t is equal to 0 students, particle is at the right extreme, that is x is equal to a. Now let's check. At time 2 pi by omega, where is the particle? So let's see. So as we see in the diagram, we have assumed t is equal to 0, the particle is at right extreme, that is x is equal to a. And let's check at t is equal to 2 pi by omega, where is the particle? So since I don't know the displacement, I have taken it as x dash. So our formula x dash is equal to a cos omega t. Now students, omega t, in this case we have taken the value of t as 2 pi by omega. So omega t is written as omega into 2 pi by omega. I can cancel omega and therefore omega t becomes 2 pi. Now cos of 2 pi is again 1. That means x dash is equal to a. Very important conclusion students. T is equal to 0, x was a, and t is 2 pi by omega, x dash is also a. That means the particle takes a time 2 pi by omega to return to the extreme position from where it has started. So can I say in time t is equal to 2 pi by omega, the particle has completed one oscillation. But we know time taken to complete one oscillation is nothing but time period. And hence students, I can say time period will be given by the formula t is equal to 2 pi by omega. So in this way, we have derived expression for time period here. Now, let's move ahead. As we know, omega square is k by m. So omega will become root of k by m. Let's substitute it in equation 1 and therefore t becomes t is equal to 2 pi upon root of k by m. If it rearrange properly, we'll get it as t is equal to 2 pi root of m upon k. Another formula for time period in this chapter, oscillation. Remember students, in the numericals of spring mass oscillator system, we will use this formula for time period. Let's move ahead students. As we know, omega square is k by m. Let's express k. F is kx, formula for restoring force, and hence k, force constant, can be written as force per unit displacement, F upon x. Let us substitute this value of k here and I can write omega square as F upon x upon m. Let us rearrange this and omega square therefore becomes F upon m into x. Students, from Newton's second law, force is equal to mass into acceleration, F is ma. So F upon m can be written as acceleration a. Therefore, in the formula of omega square, I can write instead of F upon m, I can write a, and therefore omega square finally becomes a upon x. And hence omega rate becomes root of a upon x. In words, therefore, I can write omega is therefore root of acceleration per unit displacement. As we know, t is 2 pi by omega. Let's substitute this value of omega in this expression and hence time period can also be written as 2 pi upon root of acceleration per unit displacement. So we get three formulas for time period here: 2 pi by omega, second 2 pi root m by k. Root of acceleration per unit displacement. So we get three formulas for time period here: 2 pi by omega, second 2 pi root m by k, and the third expression is 2 pi root of acceleration per unit displacement. Let's move on to frequency, students. Frequency, we know number of oscillations per unit time. So let's define it here once again. So number of oscillations completed per unit time by a particle performing SHM is called as frequency of SHM. As we know, frequency is reciprocal of time period. So one formula we know already, it is f upon t. T is 2 pi by omega. Therefore, if I substitute it here, formula frequency also becomes omega upon 2 pi. Students, we have already seen this in our chapter circular motion also. And as far as this chapter is concerned, we know omega is k by m, and hence frequency, students, can also be expressed as 1 upon 2 pi, and the formula of omega, that is root of k by m. F therefore becomes 1 upon 2 pi root of k by m. Frequencies, units we know, students, unit, SI unit is hertz, even CGS unit is hertz. So in this unit, students, we have defined time period and frequency, and we have seen the respective formula for time period and frequency, students. See you in the next module, students. That's all for this module.